In this lesson, we're going to learn about something called slope. I can apply my understanding of finding distance between 2 points in a coordinate plane and interpreting graphs so that I can determine the slope of linear graphs. I will know I've got it when I score an 85% or better on the assignment over the lesson. Okay, to start off with, we're going to define what a slope is. The slope of a line tells us the direction and steepness of that line. And the variable we use to represent slope in math is, for some reason, the letter m. Not sure why they picked m, but they picked m. So the slope of a line tells us the two things, the direction and steepness of a line. Slope is also referred to as a rate of change. To find a slope, we will draw a right triangle. And we'll draw that right triangle between any 2 points that are on the line we're trying to find the slope of. So we're going to pick any 2 points on this line to illustrate how we're going to draw this right triangle. It's best to pick points that are not decimal or fractional points. So you got to find points that hit on a T where the two all whole numbers will meet. So we can pick like 0, 0. And we can use 3, 2. Another point that is obvious and lands on a T would be right here at 6, 3. And another one would be at 9, 6. Sorry, that's 6, 4. So any of those points, there are solid points to use to make this right triangle. So I'm just going to pick any 2. I'm going to go with 3 and 2 right here, and I'm going to draw a segment going straight up. And then I'm going to go from here over to that next point. So I drew a right triangle here where my 2 sides here that meet at 90 degrees will form that 2 sides, and this right here is the third side of that triangle. Okay, and then once we have that, we want to count the vertical change. Remember, vertical is the up and down. That's why it's that green line matching my green word here. The vertical change, and divide it by the horizontal change, which is the left to right change. So my vertical change, as you can see, if I count, I went up 2. And then my horizontal change, as you can see, I went to the right 3. And I'm using directional words. Up is positive, right is positive. So I went up 2 and right 3. And this is known as the rise. That's your vertical change. How much did we rise? Over the run. So we're going to write this now as the rise over the run. So the rise, the up and down, we went up 2, and the run is 3. And a slope is written as a fraction, and the fraction will either be an improper fraction, and we'll leave it an improper fraction, and it'll need to be in simplest form, reduced to lowest terms, or a whole number, and which can be an integer. So we're going to leave our fractions as either improper fractions in lowest terms or in whole numbers. So the slope of this line is 2 over 3. It's the rise 2 over the run 3. The change in the y direction over the change in the x direction. And we went up and right. So that's the process we're going to use when we have a graph and you're asked to find the slope or the rate of change on the graph. All right, we're going to practice together finding the slope of these 2 lines right here. But before we do that, remember when you rise up, it is a positive direction. And if you run on the x to the right, you're running in the positive direction. If you rise down, it would be falling. Technically, it would be a negative direction. And if you run to the left on the x-axis, you're going in the negative direction. Slope is two things. It's the direction you're going in, the direction the line is going in, and there's a value for it, which is the change in your y compared to that change in your x values. We're going to start with our rise. I need to draw a right triangle to get from this point down here over to this point up here in the first quadrant. So I rose 3 and it was up 3, so positive 3, and then I ran to the right 6, so positive 6. So our rise compared to our run, the y value change goes first, and we went up 3 to get to that other point. So it's rise 3, and then the run is 6, which we get 3 over 6, and that reduces to 1/2. So this would be our slope in its reduced form. One of the mistakes students make is they write it backwards. They put the run over the rise, and that is not how slope is defined. So you need to make sure that you rise before you run. Before you can actually run, you got to get up. So rise before you run, rise on top, run on the bottom. Y change over X change. Okay, we have the same line below, and sometimes students don't go in the same direction as other students. So when we look at this, but we can still get the same answer even though we do it differently. When you look at this, we started with the point on the left, and then we went to get to the point that was further right. So going from left to right to get to that. But some students might start with this point and want to go from this point to this point over here, the backwards to what we just did. So we're going to do that to see what happens when you go in the reverse order. So I'm going to start with the rise. I always like to start with the rise because that's what's going to go on top of my fraction. The rise for this is -3. We went down 3, and then we're going to go to the left 6. Left is negative, down is negative. So both my rise and my run are negative values. Left 6. So you end up with your rise on top, -3, and the run, -6. But when you reduce this, you have a negative divided by a negative, which is a positive, and the 3/6 reduces to 1/2, just like the problem above. So even though we went in different directions to make our right triangle, the signs work themselves out. So in these 3 problems, we're going to practice finding the slope of the graph line. So again, you can pick any 2 points you want that you can clearly read. Easiest way to go is pick those whole number ordered pairs and then use those to find the slope after you've drawn your right triangle and made your counting. So the ordered pairs I am going to use that I thought were pretty clear to read were 2, 4 and 4, 7. So to find the slope, I'm going to go left to right. I'm going to find this point here to get to this point over here that's further right. So to do that, I'm going to do the rise first. And my rise is up 3, so I put a 3 over here on my m equals. Remember, m stands for slope. And now I'm going to do the run, which means I'm going to make my move to the right. And that was two steps to the right to get to that point. So my slope is a rise 3, run 2. And we leave it as an improper fraction. You will not change these to mixed numbers. Just leave it as is. Just make sure it's in lowest terms. 3/2 is in lowest terms. We want to be able to see the change in the y value compared to that change in the x. Since both were positive, I ended up with a positive 3/2. If you chose to go in the other direction, you would have a -3 because you went down 2 and a -2 because you went left 2. And that would work itself out to 3/2 as well. Okay, on this one, I'm going to pick 2 points that I can clearly read. I think we're at 0,9 here. And then right here is a good point. I'm going to use these 2 points to find the slope of this line right here. So to get from this point to this point, I started with my rise, which was down 1. So it's a -1 for the rise. And then I'm running to the right. and I'm going from 0 to 4. So my run to the right is 4, positive. So the slope of this line is negative 1/4. If you happen to do this backwards, you would have gone up 1, so your top number would have been positive 1, your rise, and then left 4, the bottom would have been a negative. And you would have had a positive number over a negative number, which would also be negative 1/4. So direction doesn't matter that you choose to go in. So for this next one, I chose the point, any 2 points. I can pick whatever I want. I chose 0, 2, and 2, 8. So we're going to start with the rise. And the rise went from 2 to 8, so the rise was 6 up, and then right 2. So it's 6 over 2. Now that is not in lowest terms, so we're going to reduce that. And I will divide 2 on the top and bottom, which comes out 3 over 1. But for slope, we're just going to leave it as 3. We can leave our slope as a whole number or an improper fraction in lowest terms. So 3 would be your result for that slope. That would imply that there's a 1 in the denominator and we don't write it. You're expected to know it's a rise of 3 compared to a run of 1. You might say, hey, it was 6 to 2. Well, watch what happens if we rise. Let's get a little example here. We could have picked the point right here. And you can see it would be a rise of 3 and a run of 1. And then if we took another step, a rise of 3, we'll hit that second point. So it's like we took one giant step instead of 2 little steps. And the giant step was not in lowest terms. Okay, I want you to try out number 4 to see what you get for your slope. So you're going to pick 2 points that you can clearly read. And then you're going to count out the rise. Write it in the numerator, count out the run, write it in the denominator, and watch the direction. If it's a negative direction, you need to put the negative in for your rise and your run. Turn the video back on when you're done to see if you've got it correct. Okay, I chose the point 0, 3 and the point 3, negative 1. And I got that I had to go down 4 when I made my right triangle and right 3 to get from the first point here to this point. If you did it differently, and you could have gone up 4 if you went backwards and left 3. Up would be positive 4 over negative 3. Either way, we end up with negative 4/3 for our slope. Okay, try out this next one. We're doing rise over run. Find this 2 points. Make your right triangle, watch your direction, positive, negative, and come up with the slope for this next line. Turn the video back on when you're done to see if you got it. Okay, so I chose the point negative 4, 0, negative 4, and 2, 1. And I had to go up 5 on my right triangle side and across to the right 2. Both are positive directions. So my slope was 5 over 2. It's in lowest terms, and I'm leaving it as an improper fraction so I can see the 2 changes against each other. If you happen to go in the other direction, to go from this point that's further to the right down to this point to the left, you would have gone down 5, negative 5, left 2, negative 2. Negative 5 over negative 2 can be simplified to 5 over 2. All right, try the next problem to see how you do. Okay, you had to be careful on this graph because you have to watch your intervals. So if you were careful, you notice that they were counting by 2s on the y-axis and only 1s on the x. So if I chose to go from negative 4, negative 6 across to 0, negative 4. So to get from this point, I had to go up 1 step, but that's 2 units. And then I had to go right 4. Because I went from negative 6 to negative 4, that's 2 units here. And then I had to go from negative 4 to 0, which is 4 units. So it was 2 to 4, which reduces to 1 over 2. And I was going in positive directions for both the rise and the run. So it's 1 over 2. Okay, so you are going to need to find the slopes for these 3. Hopefully you've got the hang of it now. And when you're done finding the slopes for these 3 lines, turn the video back on to see how you did. All right, so again, the interval on the y here is counting by twos. I went from this point, 0, +8, to 2, 2. And to get from this point to this point, I had to go down 6. It was 3 steps, but each is worth 2, 2, 4, 6, down, -6, and to the right 2 units. So -6 over 2, which comes out to -3. Remember, it's -3 over 1. Rise, -3, run, +1. The 1 is not there, it's implied. When you're told that's the slope, you got to remember there's a 1 under there for the run. Okay, this next one, we're counting by 5s on the y and only 1s on the x. So on this one, we had to go down 1 step, which is down 5. I used this point 0, 15 and this point 1, 10. So I had to go down 5 and I went right 1. So my slope is -5 to 1, and when we put it in its reduced form, it's -5. And finally, this final graph, they're also counting by 5s on the y's and only 1s on the x's. So I chose to go from 0 to the point 420. So to get from my rise, I had to go up 4 steps, 2, 3, 4, which is 20 units, up, which is +20, and then 2 units to the right, which is 2, and 20 over 2 reduces to 10 over 1. So the rise is 10, the run is 1. We don't write the 1. You have to remember the 1 is part of that slope, and it's the run. All right, so there are 4 types of a slope, and these are based on the direction the line is running. So we're going to read each of these graphs. We're going to look at the direction they're running, looking at them always from left to right, just like we read. So we're looking at this line right here, and we're going in this direction. So what's happening to the line as we work left to right? Well, the line is increasing, we say. As x gets bigger, as we move to the right on the x-axis, the y value is also getting bigger. So we say that that graph is increasing. It has a positive slope. So you can look at a line and know whether your sign should be positive when you're done getting the slope or negative, just by seeing if it's increasing as it looks to the right. This next one, as we read it again, left to right, we look here, what's happening to this line as we move right? It is falling. We say that it's decreasing. What's happening is, as we move right on the x-axis, our y values are going down. They're running in opposite directions. As the x increases, the y decreases. Here they're both increasing, here they're opposites. So we say that it has a negative slope. So you can look at a line and you would know when you're done getting your value for that slope if there should be a negative sign on it or not, just by looking at the direction of that line. A 0 slope, as you can see, this is a horizontal line. When there's a 0 slope, then your line is running parallel to the x-axis. It's horizontal. And that's when you get a 0 for your slope value. An undefined slope is a vertical graph of your line. It's running straight up and down. And we say that that slope is undefined. Doesn't exist. There is not a number to describe this slope. 0 describes this one. Your value coming out of your slope for m will be positive if it's running or increasing. And then it'll be negative if it's decreasing. So you can look at graphs and really know a lot about the slopes without actually having that slope value yet. Okay, so we know that the slope is the steepness of a line of a graph, and we can calculate that as the ratio. Remember, a ratio is just a comparison, and that's exactly what we're doing with the slope. We're comparing how much it rises compared to how much it runs. So the ratio is the vertical change, or the rise, over the horizontal change or the run. Okay, so the top number for the slope formula, this is the rise on top, the y change compared to the run on the bottom. The run is the left to right x change. So remember, when we find change is always subtraction. If we're trying to find the distance between 2 points, it's a difference. It's a subtraction. But since we have a rise and a run changing, we will write it as a ratio to find the steepness. So how to use the slope formula? First thing you need to do is you need to identify the two slopes that are on the line and write down the coordinates. So let's say we don't have a graph to show us, but we were looking at a graph. These were 2 points that hit a line. So we just wrote them down as an ordered pair. We're going to label each of these points x1, y1. So here's the first point. It's x1. I'll write it underneath, a little more room. My first number is x, so that's x1, and my second number is y1. So that's the first ordered pair. And then the second ordered pair, this is going to be x2, and this will be y2. We say sub 2. All right. So we have labeled where our coordinate, what each coordinate is, and then we're going to take the y2 minus y1. The rise is going to be on top, and the run is going to be in the bottom. But before we do that, we're going to do another method where we stack our ordered pairs. So this is another method you could use to keep things straight. So I'm just going to put 6, 3 on top. Doesn't matter which one you put on top or the bottom. Negative 4, 2 on the bottom. I could flip those over, it doesn't matter, it'll all work out. So the stack method is just stack the ordered pairs and then decide your rise and run after you stack them. So when I look at this, I see that I went from my x's run across from 6 to negative 4. So if I'm thinking about the graph, if I start on 6 on the x-axis and I run to negative 4, I ran left 10. Now I'm going to look at my change in my y. Remember, this is the x, so it would be the run. My change in my y, it starts at 3 and then it goes down to 2 on my y. So that would be the rise, and it would be negative 1. Okay, so stacking them. So if I'm looking at the stack them method, I'll write over here what I got is negative 1 over negative 10, which is 1 over 10. So you can think of it like that, or you could use the formula. The formula will also give us that value. So it's y2, which is positive 2. Here's my y2, positive 2, minus, I'm looking at my y1 is 3. Okay, so there's my rise, my y2 minus my y1, and then my x2, which is negative 4, minus my x1, which is positive 6. So now I just do this subtraction. 2 take away 3 is negative 1. Negative 4 take away 6 is negative 10. And a negative divided by a negative is a positive. So I get a positive 1/10, 1 over 10, fraction in lowest terms. So stack them. Gives you the answer, the correct answer, or the formula. You should know how to do both. The stacking just is a good way to check yourself, and easy strategy to use when you're dealing with very easy numbers. Okay, so we are going to practice doing the stacking method on these 3 right here. So the first thing we're going to do is we're just going to write our ordered pairs. It doesn't matter which one you put on top, which one you put underneath. The signs will always work themselves out, just like they did when we were graphing earlier. So I just stacked them, and I have my x's first and my y's second. But when I write the slope, remember it's rise over run. So here, to get my x right here, to go from 4 to negative 2, I have to run in the negative direction 6. Just keep straight, that's your run. And then to get from -1 to +7, I have to rise +8. So my slope is 8, the rise, over the run, -6, but that is not in lowest terms. So we got to put it in lowest terms by dividing 2 out of both, the top and the bottom, and we get a -4/3 for our slope. All right, I want you to go ahead and try this one, stack them, and then turn the video back on once you've got your slope figured out. So you should have found the rise is 8 and the run is 4 when you stacked them. And they're both positive. So it's 8/4, 2/1, and then 2 is your slope. If you flip these over, you would have a -4 for your run and a -8. So if you wrote this one on top and the -5, -3 underneath it, you would just have 2 negative numbers here, and that would still work out to +2. The signs will work themselves out. Okay, here we have 3 ordered pairs that they gave to us that are on the same line. So you get to choose any 2 ordered pairs you want to find the slope. Just so we're consistent, I'm going to have you choose, let's have you do this ordered pair right here and this ordered pair right here. So use those 2. It doesn't matter which 2 you pick, but I'm going to have you use this one and this one, and use those to stack them and then find the slope value. Turn the video back on when you're done to see how you did. So on this one, you should have gotten 7/8. Had you used these 2 right here, we would have gotten 3.5/4, and then you would just try to clear that decimal in your fraction. And if you clear that decimal, you would just need to double the 3.5 to get rid of it, and it would be 7/8. So it does work itself out. You just have this one that's not really in its simplest form with whole numbers for the numerator and denominator, but it would work out. It's equivalent. It's an equivalent fraction for 7/8. Okay, so for this one, we're going to use the formula to figure out the rise over the run. So first thing I want you to make sure you do is you label your x1 and your y1, your x2 and your y2. So I would call this x1 and this one y1. And then this would be x2, y2. And then what you're going to do is you're going to set up your ratio. M equals. Remember the formula is y. Let's see if I can fit it here. Here's the formula. M equals y2 minus y1, that's your rise, over x2 minus x1. So go ahead and find your slope using that formula, and then turn the video back on when you're done to see if you got it correct using that formula. All right, when you computed the change in the y's, you got 0 change. And then when you computed the change in your x, you should have gotten 8. And if you reverse these and you did this one, well, we defined it as x1, y1, x2, y2, so you should have done it in the same order, okay? So this slope is 0. 0/8 is just 0, and that means you have yourself a horizontal line. And if you think about it, your x's are your y's are the same. So if you're on the same y value, you're running horizontal parallel to that x-axis. Okay, the next one, we're going to pick 2 of the points to use here. Let's just use these 2 right here. So you're going to plug those into the slope formula right there, and redo that. So plug it into the slope formula right there, and then turn the video back on to see if you got the correct value when you're done. All right, so on this one, when I use these two at below as the x2, y2, so I had 7 minus -5, which came out to 12 because the double negative is a plus, and then 5 minus -1 came out to 6 because that double negative is a plus. 5 plus 1 is 6. 12 over 6 reduces to 2 over 1, and that is just 2. So my slope value is rising 2, running 1. Now, when you look over here, if you reverse those, if you called this x2, y2 and this x1, y1, you would have had a -12 here and a -6 there. Our signs would have just come out opposites if we reversed, and that's still 2 over 1. All right, try this next one out. You're going to use the slope formula to figure out your slope. When you've got it, turn the video back on to see if you did it correctly. So when you did your math, you should have gotten, if you picked these two as your x2, y2, it was -4 minus 2, which is -6, over -2 minus -2. That double negative is a plus. So -2 plus 2 is 0. We got a 0 in that bottom denominator. You cannot divide a number by 0. If you have -6, you can't divide by nothing. You have something. So it's called undefined. Can never divide by 0. It doesn't make any sense. So when we have an undefined slope, when we have a 0 in that run, it is a vertical line. So this undefined situation means you have a vertical line. If you think about it, your x's are exactly the same. So you're running through, if you think of coordinate plane, here's your -2. You're running through 2 points that are both at -2. So you're running this vertical line. When your x's are the same, it's vertical. When your y's are the same, it's horizontal. Okay, now we're going to practice applying what you know about a slope and a line. And so we have a slope that was given to us. The rise is 3 and the run is 2. And they say, hey, you got to graph the line that has a slope of 3 over 2, and it goes through this point, 0, -4. So they gave us enough information to make a line out of this. So we're going to start with this point right here. When they give you a point on a line, that's where you're going to start. Okay, from that point, I am going to rise 3 and run 2. This is like a stair step. Okay, so I'm going to go up 3, and then I'm going to go right 2. Make that right triangle, except for I don't have this line yet, so I'm just making the triangle. Then I'm going to plot a point there. And I can stop there because it only takes 2 points to make a line, but I'm going to continue with my stair step because that slope is consistent on this line. So I'm going to go up 3 again and right 2. And I'm going to plot that point. And you can see that we're forming a linear pattern here because we have a constant slope. And 1 point, we can make that line. Now I'm going to connect them up. I'm going to go past that point I first made. I'm going to draw arrows on it. And now I have drawn the line. I graphed the line using just a given point in that consistent stair step 3 to 2. Okay, just to point out again, sometimes we take bigger steps. If it's 3 to 2, I could go up 6 to 4 because that is an equivalent fraction or 3 halves. So equivalent fractions on this will also work to find points that hit that line. Not necessary here, we just use 3 to 2. But just pointing out that there are equivalent fractions happening with your slope to, and they'll all hit the line no matter which fraction you choose to use. Okay, so I want you to try this one. Start with this point right here, plot this point, and then you're going to do a slope of -5/3. When you're done, turn the video back on to see if you graphed the line correctly. Yes, so on this one, you should have a falling, decreasing line as you read it left to right. So it should have gone through the points -2, 1, which they gave to you, and then the other point when you went down 5 and right 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You should be at 1, -4. So that should be it. Now notice this is a positive slope because it's increasing to the right, and this is a negative slope. It's decreasing to the right. So you should have a sense of how that line should be running before you graph it, right? So you can check yourself. This is a negative slope. This should be falling to the right. This is a positive slope. It should be increasing or rising to the right. And they are. That's just a check that you should always run to make sure you're falling and rising correctly. Okay, this next one we'll do together. They gave us the point -4, 3. So we're going to start there, -4, +3. And they say, hey, it's a slope of 0. So this is a horizontal line. Because it has a slope of 0, you need to just know, hey, this is running horizontally. It means that my y values are staying the same. They're all the same. No matter what ordered pair I decide to use to form this line, the y value will not change. So it could be here. You could have picked this point. Any point that runs through +3 on this is going to work. Oops, that's kind of thick. So when it's a horizontal line or they tell you have a slope of 0, that is giving away that your y values are all the same. You need to recognize that. It needs to just be built in that this is a 0 slope horizontal. Y values everywhere on this line are 3. So this is 0, 3, 0, 3, 2, 3, 5, 3. It's always going to be 3. On this one, they're telling you the slope is undefined. Automatically, you should recognize that the line you're drawing is a vertical line. Before you even begin or even look at this point, that tells you you have a vertical line. It tells you that your x values on this line will all be 2. There's no change for your x. So 2, -1 is where we're going to start. Plot your point, 2, -1. But I already know that any point I pick has to just fall in a vertical pattern. It doesn't matter which one you decide to use there. Your x value is always the same for vertical lines. Whoa, that's not my line tool. So just draw your straight line through x is 2. X is always 2. So they gave us 2, -1, but we could have pick 2, 2. 4, 2, 5, 2, oh, I'm saying it wrong, sorry, backwards. 2, 2, 2, 5, 2, -1, 2, -5, 2 will always be your x value for any point ordered pair on this line. So just to recap, slope is the change in y over the change in x. And slope always focuses on 2 things: the direction that the line runs and the change in y over the change in x value. We get our change in y by subtracting our y coordinates. We get our change in x by subtracting the x coordinates. And then we make sure we write that ratio either as a whole number, that's an integer, could be an integer, or it can be an improper fraction that is in its lowest terms, reduced form. There are 4 types of slope, remember. There's the positive, which increases to the right, the negative, which decreases to the right, the vertical, which is an undefined slope, and then the horizontal line, which has a slope of 0. That concludes the lesson, so you are going to go to your assignment. Good luck on that assignment.